Okay, let's do this angle versus distance lab. And, like it says today, we're going to do another experiment. This time we'll be finding out how angle affects distance. So click this generic lab. That'll take you here. First thing you need to do is make it yours. Otherwise, you won't be able to edit it at all. So hit File, Make a Copy. And let's do, instead of independent, we'll say, let's say our name, and then it'll be angle versus distance. And it's not a generic lab. So wait for that to make a copy. And let's get right to it. Let's replace the title with, instead of IND, it'll be angle. And I think I'm going to go all caps. Angle versus distance. And here I've highlighted everything I've highlighted. I want you to replace with, what it actually is. So it'll be angle and distance. Distance. How does the angle of a cannon affect the distance? Cannonball, and I want that not capped or not bold, so cannonball goes. All right, and let's use the format painter. I'm going to click here, grab the paint format thing, and just take away. Actually, I'm going to lose my bolding because of that, but I'll just swipe and bold, double click and bold. Darn, it looks like I still have a little piece of highlighting there. There, now it's gone. Okay, so how does the angle, and I've labeled it IND, of a cannon affect the distance? So it's very clear to me. It's a well-written question where I can see what the independent and dependent variables are. And the question itself, written this way, really implies what's going on. Like, in other words, if I were a stranger and I read this question, I would pretty much know what your experiment is going to be about. So here I want to replace this with angle. Angle, it's a short word, so I can just leave it like that. And then I'll say dist here. And I want to take away the highlighting, so I'll format paint. Okay, so for the angle, I guess the truth is you'd need to experiment a little bit with a cannon and actually get a range, because I wouldn't want you to go 1, 2, 3, 4. If those are your angles, you would not be happy with the results. And if you went 10, 20, 30, let's see, 10, 20, 30, 40, 50, 60, 70, 80, 90, that's not too bad. Yeah, I mean, if you experiment with angles, you see that the interesting stuff's going to happen from 0 to 90. So I don't know, maybe 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Let's do that. Okay. And we're going to put our graph here. That'll come later. The procedure, you would just, like it says there, I want you to explain it as if you were doing it in real life. So set the cannon at 0 degrees. Load a cannonball in it. Chamber and fire. Measure the distance and record in the data table. You might want to also find a football field to set up to perform the experiment on. That'll help you measure the distance. Okay, so after you fire at 0 degrees, then set up the cannon at 10 degrees for the next angle setting C data table equals 10. Let's say like that, because that's what I'm trying to communicate, is that we're getting it from the data table right up here. Then, and repeat, do this same process for all angles. Okay. So now that we've written our procedure, we know that we need a football field and all these other things. Let's see. I'm gonna take the bolding off. Control B will do that. Football field. Cannon. Cannon balls. Protractor. That's to measure angles. Tape measure. Or yeah, you'd probably need a tape measure to sort of supplement your football field thing. Let's see it. Long tape measure. What else would we need? I'm guessing that's probably good. So the hypothesis I want in this format, if I increase or decrease, you got to make up your mind, the independent variable, and remember the independent variable is the angle, and I don't want the highlighting there, so I'm going to take that off. I need any football player. Okay, let's see. So if I increase, and I'll just say if I increase the angle of the cannonball or cannon, I don't want the highlighting, so take that off. Then the dependent variable is distance. And once again, I don't want the highlighting, so take that off. Then the distance, the cannonball will travel, or goes, how about that? Will increase linearly. Sure. And I wrote in here, sometimes it's exponential, sometimes it's logarithmic. Not super necessary that you know what those are, but sometimes it just helps explain your prediction a little bit better. The cannonball will go, let's see, if I increase the angle of the cannon, then the distance the cannonball goes will increase linearly. Because, yeah, so there's blah, blah, blah. Because the greater the angle, the more, the further it will go. We'll say that that's my prediction, even though it's wrong. I mean, it's right to some degree. There's a limit to it, as we'll see. All right, so once again, now we've got our independent variable and dependent variable. That's very easy. It's independent and dependent. Angle, distance. Anywhere it says independent, it should say angle. Anywhere it says dependent, it should say distance. So once again, here, it should be distance. I don't want the highlighting because that was just for you. And this will be angle. Right, so then here, constants. These are the things we're going to keep the same. Make sure the field you use is very level. Isn't that true? Of course. And I would imagine if you found a football field that it would be level. But, you know, maybe if you were in a third world country, I've seen soccer fields in Brazil that weren't perfectly level because they just, you know, grabbed a field and decided to play soccer on it. So make sure the field you use is very level. Let's see. Make sure the lines marking the distance are accurate. Make sure there is no wind, because that would mess up your results. Use the same cannonball for all trials. Same protractor. Same measuring tape. So constants are just things that you're very conscientiously making sure you keep the same. And if you're catching on to this, everything should be the same except for the angle should change, and even that should be controlled and very accurate. Your conclusion, once you find out if you're right or wrong, because remember you made a prediction over here, if I increase the angle of the cannon, then the distance will increase linearly. So in the conclusion, you might say, the data supported my hypothesis. As I increased the angle, the cannonball traveled a greater distance. So that might actually end up being, you have to do the experiment to see if that's true. Uh-oh, my keyboard's lagging. Yeah, all of a sudden it's going to catch up in a second. Sorry. I guess I'll pause the video till this clears up. Okay, it's back. So I'll take off the highlighting, and I don't need the quotes. Uh-oh. Now it's doing it again. Okay, so the data supported my hypothesis. As I increased the angle, the cannonball traveled a greater distance. And you might say up to a point. Turns out that at the angle 45 degrees, the cannonball went the furthest. Beyond that, it began to, the distance began to decrease. Decrease, yes. Okay. All right. So then the final thing is the sources of error, where you want to say all the little things that got into, little errors that got into your experiment. So, like let's see, I actually gave an example, and that might be true. I could get rid of that. I'd say I tried to find a day when the wind was absolutely still, but it was hard to find such a day. There was a small breeze, blah blah. And we want to mention 2 or 3 different things that went like wrong with the experiment. And this is a simulation, of course, but I told you to imagine that we were actually doing it in real life. You could say, turns out there were a few low spots on the field. It wasn't too bad, but it might have a tiny effect on the results for some points. And that's true, because all these sources of error are probably just going to be small, tiny effects. Otherwise, you'd probably just redo it somewhere else, find a better place to do your experiment. So I have one more. What do I got to do? I could say the cannon I used was pretty big, and the protractor was kind of small, so it was difficult to get accurate angles. So there you go, some sources of error. And with that, you have completed your angle versus distance write-up. And of course, I've skipped the part where we actually use the cannon, and I'll leave that to you. You'll want to go here to the lab, and you might want to raise this up by clicking. Let's see, there's a way somehow to raise this up. There we go. So set it, at a certain height, but whatever height you set it, you're going to leave it that way the entire time. And then put it at 0 and fire. And find out what that distance is. The way you do that is use this tape measure. Let's see. Put it right there. and stretch that to there. And now I write 16.32 meters in the data table for this. 62.32. Is that what I got? Let me look again. 16.32. Okay, 16.32. All right, then we move to the next one. Set the angle at 10 and fire. And then measure that. Write that in the data table, 22.61. 22.61, and move on. All right. And after you build the data table, you should know how to convert it to a graph. Copy that graph, paste it right there, and you'll be done. And that's it.